So a box of mass 30 kg is being pulled. So that means we have this object over here and it has a mass of 30 kg. So this would be 3g Newton and the reaction force would be over here. Now the force that is being used, it has P Newton force and it's going to have two components. So one is going to be along the horizontal plane, the other one is going to be perpendicular to it. Since this is 20 degree, that means this is also going to be 20 degree. So this is going to be P cos 20 and this is going to be P sine 20. So these two are going to be the component. Now we know that the box is being pulled on a rough surface and that has a coefficient of friction of 0.4. So that basically means that in the opposite direction there is going to be 0.4 r, mu r, going to be 0.4 r. Okay, so horizontal components. So we know the forward force is P cos 20 and the backward force is 0.4 r. So from here, so we get one equation basically. So we can write P equals to 0.4 r divided by cos 20. Now if we know the value of r, we can find the value of P. So now we can write vertical components. So the vertical components are, so upward is r plus P sine 20 and downward is 30g Newton. So from here we can find the value of r. So r is going to be 30g minus P sine 20. So this is another equation. So if we can plug this value in the next one, so we can get P equals to 0.4, r is going to be 30g minus P sine 20 divided by cos 20. So one calculation we can do is, since the calculation is a bit lengthy, we can write 0.4 divided by cos 20. So that is going to be 0.4 divided by cos 20 and that turns out to be 0.426. So 0.426. Now we have to multiply this with 30g and sine 20. So what we have to do now, we have to multiply 0.426 multiplied by 30 into 9.8 and that turns out to be 125.2. So the box's model Newton P Newton particle is this pulled constant speed. So this is constant speed. So when we have horizontal component and if you have constant speed, that means they're equal since there is no acceleration. So it works like this. So if you have constant speed, that means acceleration is equals to 0. So since it's constant speed, that means the forward force, if the forward force is F1 and the backward force is F2, all the forward force subtract all the backward force is equals to mass into acceleration, and acceleration is 0. That means the forward force and the backward force will eventually be equal. So F1 equals to F2. So whenever there is constant acceleration, that means whenever there is constant speed means zero acceleration. Zero acceleration means net force equals to mass into 0. So that means net force equal to 0. So whenever we have all the forward forces subtract all the backward forces, that is net force. Whenever net force is 0, then we can say that the horizontal components are equal to each other because it's the same as being equal. So the calculation is going to be now 0.426. So 0.426 multiplied by P sine 20. So that is, so P sine 20, and that is 0.146. So this is going to be 0.146p. So now with this calculation, what we can do is we can send this p to the other side, and it would be p plus 0.146p equals to 125.2. That means if you add it up, it would be 1.146p equals to 125.2. Therefore, p equals to 125.2 divided by 1.146. Therefore, p equals to 125.2 divided by 1.146, and that is 109. So P is 109 Newton. Now the next one. So for the next question, so we have the tension in the rope is now increased. So the object is no longer moving with constant speed. That means zero acceleration. Now it's going to actually accelerate. So what happens now is, so the force with which it is being pulled, it is now 150 Newton. Previously it was P, now it is 150 Newton. So this is going to be the value. So the angle and everything is same. So the component is going to be, so one over here, one over here. So the angle would be 20 degree just like before. This would be 150 cos 20, and this would be 150 sine 20. And we have weight over here, which is 30 kg, so 30 g Newton. We have normal reaction force, which is R. Then again we have mu is always the same, so mu is going to be 0.4 like before, mu R. So that's the value. Now since this object is accelerating, and it is accelerating towards the front, so it is moving in this direction, in that way. So first of all we have to calculate the reaction force, normal reaction force. So we know vertical components. So we know R plus 150 sine 20. These are the upward forces, and the downward force is 30 g Newton. And then the reaction force is going to be 30 g minus 150 sine 20. So this is 242.7 Newton. Now horizontal components. So this time the object is going to accelerate, and is going to accelerate forward. So net force. So the force that is trying to pull it forward, pulling it forward, is 150 cos 20, and the force that is going to keep it backwards, frictional force, is 0.4 R. So R is 242.7. So the net force is going to be 43.9 is the net force. So we know net force equals to mass into acceleration. Mass is 30 kg, acceleration is A. Therefore A is 43.9 divided by 3, and that is going to be, so 43.9 divided by 30, so 1.46 meter per second squared.